Welcome to Learning to Engineer. We learned different concepts of RL and RC transients in this video. Later on, to test our understanding, we solved a different set of problems in the topic of RL as well as RC transients. Now, we are going to solve a bit trickier problems in this topic. The idea behind solving difficult problems is that it will be challenging our understanding. Only when we understand the concepts in a very crystal and clear manner, only when we are able to see through the concept completely, we will be able to solve these problems. Once we are able to solve these problems easily, our idea behind the concept gets strengthened. We would have had a bit doubts and we will not be very clear about the concept when we are reading from a textbook. That is the whole reason behind solving different kinds of problems, solving different varieties of problems, and then testing our understanding. So now let us test our understanding in the topic of RL and RC transients. Let's get started. The first question is, find the value of Ix in the following circuit at 1 second intervals from time t equal to minus 0.5 seconds to t equal to 3.5 seconds. We have three sources here where two are time dependent voltage sources and one is a time dependent current source, meaning that at different levels of times the power supplied by each one of these sources will vary. Let us first understand the circuit better and then begin solving it. Two voltage sources here. This is a kind of negative voltage source and this one is a positive voltage source. What is a positive voltage source? It means it will give 100 volts at one particular time interval. But this one is a kind of negative voltage source because the time is 3 minus t. So if we understand, this can be said that unit step signal of minus t minus 3. So this is a kind of negative voltage source and this also sweeps towards the left side. This is a negative current source. I will explain you better. This is a unit step signal u of t. This signal will have a steady output of 1 volt at all time greater than 0. That is u of t. When I say that this signal is delayed by the time t1, let us say this is 9 o'clock and the signal is active only from 9 to. Okay, so from 9 to am this signal is active. This signal will be represented by a delayed time of t1. So this will be u of t minus t1, meaning that it is not 9 o'clock. It is delayed by some amount of time. So this time is t1. So this signal is represented as u of t minus t1. Consider this signal. How will you represent this signal? Just think for a moment. It's just similar to this. It's more analogous to the concept that we learned earlier. So this signal is u of t plus t1 because it is ahead of time. I told that this is 9 o'clock for example and this is 9 to. If a student comes late by 2 minutes, we can say that the time interval is t minus t1 or it is delayed by 2 minutes. Now, this student is coming at 8:58 itself. Okay, so let us call this time as 8:58 am. So, this person comes ahead of time. So, this signal is u of t plus t1. Okay, so this is how unit step signals are represented. Let me go to the flip side of it or the reverse of this signal. It is positive for the time interval t1 till infinity. For the time minus infinity till t1, this is off or this is negative or there will be no output before the time t1. Only after t1 it will send a steady state output of 1 volt throughout the time till infinity. Okay, so this is how this signal is. If I say that the signal looks like this. till the time t1 this signal is active. At t1 it is put off. Consider this case. The output is 1. So this can be said as u of minus t1. Because this is the positive side. The signal is active from t1 till infinity. So if I take a mirror image of this, or the signal that is exactly opposite to this, it should be on, or the signal should have a steady output till the time t1. So this is what this represents, u of minus, meaning that when you have a time at negative value, this unit step signal is active. That is what is the meaning. To a flip side of it, you can say that till minus t1, this signal will be active. So to the flip side of it, you can tell this as this signal will be showing a steady output of 1 volt till the time minus t1. You can consider that this is 8:58, this is 9 o'clock and this is 9:02. If you consider an analogy like this, you will be able to graphically represent each of the unit step signals. This much basics of signals and systems is enough for you to understand this problem better, because only when you understand the time interval or the time where the switching of the voltage happens or the switching of the current happens, you will be able to understand the transient part of this circuit. Here if you observe, you don't have any inductors here, you don't have any capacitors here, you only have differently timed voltage sources and current sources. So it will be easier for you to put this analogy to each one of these power sources and then solve this problem, because this unit step signal is actually considered that this is a switch. Okay, this means that this signal is 25 u of 3 minus t, right? This can be said as 25 into u of minus t minus 3. Okay, we know that 3 minus 3 will look something like this. t1 is 3 seconds. So this signal is u of t minus 3. We want u of minus of t minus 3. So this is this one, which means that this signal condenses till the third second. From the third second it is 0, or the voltage will be 25 volt till the third second, because the value of this is 1. So it will be 1 till minus infinity till third second. After the third second till infinity, this is going to be 0. So 25 into 0 will be 0. Okay, so this has two conditions. Minus infinity till 3 and then from 3 till plus infinity. So in this condition, this is off, means 0 volt. But from minus infinity till 3, it is conducting. It is on, or this sends 1 volt. So 25 into 1 will be 25 volt and 25 into 0 will be 0 volt. So in this time interval, this has 25 volt, and in this time interval, this has 0 volt. So this acts like a switch, like a off switch. The switch is put off at time t equal to 3, meaning that at time t equal to 3, the voltage across the ends will be 0 volt. Okay, so that way you can imagine this unit step signal. This is a different way of telling you that there is a switch acting there. Okay, similar is the case for this, similar is the case for this. Okay, so first we will plot the graph of all these three unit step signals, find out the voltage conditions of each of these power sources, and then we can find out the value of I of x easily. I have told you the method. If you have understood this concept better, you would have solved this problem by now. You can pause this video, think for a moment, go through the concepts that we learned now, and then try to solve this problem by yourself. It will be very nice if you could solve this problem by yourself, because once you learn a concept, once you solve a problem all by yourself, you will face kind of dead ends here and there, you will face confusions, you will get new ideas, and at the moment you get the concept through, and at the moment you get the correct answer, you will get a good feeling of solving the problem. You will be confident that you are thorough in that concept. So only for that I am suggesting you to pause this video and then continue solving the problem by yourself, and then check if my answers are right. That way I can say that if my answers are right, then you are confident in your approach. Okay, so this is how we represent the signal 25 into u of t minus 3 or this voltage source. Let us represent this voltage source, this current source. Now let's plot this 100 into u of t minus 1. It means that this signal is delayed by 1 second, or from time t equal to 1 second, 100 volt will be sent by this voltage source. Okay, so at t equal to 1 second, at t equal to 2 second, at 3 equal to 0 till infinity, you will have a output of 100 volt. So before that, before 1 second, you will have 0 volt. Only at 1 second it will step up to 100 volt and it will remain constant till infinity. Yeah. So now we have plotted all these three voltages. We need to find out the conditions at all these times. We know that this switch is put off at 2 second, or at second this switch is put off, and thus you have a short circuit. So this short circuit will eliminate the need of 50 ohm resistor, because current chooses the easiest way to go. So the current chooses the least resistance path. The current will come here, move to the short at t greater than 2 second, and then it will circulate back into this circuit. Till the second you can consider this 50 ohm. After 2 seconds this path will be put off. Okay, so this is how this circuit is designed. Let us find the value of Ix of t for all these time intervals. So at first t1 equal to 0.5 seconds, let us understand the voltage levels. At t equal to 0.5 seconds, four things will happen. Four things are time dependent, or four switches we have in this circuit. One is here, here, then here, and then this one. Whenever you see a unit step signal, you should understand that it is a timed signal, or it is just like a switch. Okay, so at t equal to minus 0.5 seconds, what will be the output of this voltage? It will be somewhere here. Okay, so this will be sending 25 volt. For time being, I will replace this as 25 volt. Now I am considering T1 as 0.5 second. So this is sending 25 volt. And what about this? At t equal to minus 0.5, at all negative values of time, this will be positive, or this will be sending 2 ampere of current till time t equal to 0. Okay, so now I am replacing this as 2 ampere. Remember, even though I am rubbing on this, it means that this current will be sent only for this point of time at t equal to minus 0.5 seconds. Okay, so at minus 0.5, what will happen to the switch? The switch will be in open condition at t equal to minus 0.5. Only at the second this is put off, or this is considered as short circuit. For now, this is a open circuit for us. Okay, so what about this voltage source? At t equal to minus 0.5 seconds, there will be no output. The output will be 0. So 0 volt is the voltage across these two ends. What does it mean? It means that this is a shorted path. This is 0 volt now. What does it mean? It doesn't supply any voltage, or this is a shorted path at time t equal to minus 0.5 seconds. Let us find out the value of Ix given this condition. Now it is just a matter of child's play for you, because all the confusing terms has gone. You have a very simple circuit to solve. You have a 25 volt in series with 50 volt, and in parallel to this configuration you have two things. One is a 25 ohm resistor and a 2 ampere current source. Then you have 50 ohm in parallel with this setup. Okay, since you have an open circuit, no current flows here. Since you have a short circuit here, the current flows from here to 50 ohm to this shorted path and then back to the source. Okay, so you have only one pair of nodes for this circuit. I am considering that this is a reference node. You can do source transformation here to find out this as a voltage source in series with the resistance. Click this link to watch a video on source transformation technique. You have two sources here. You can choose between source transformation technique and superposition theorem. I am going to apply superposition theorem for this case. If you feel like applying source transformation technique, you can very well do that and find the value of Ix of t. That is the objective of us. Okay. So Ix of t will be the current supplied by 25 volt plus the current supplied by 2 ampere. I am putting it as Ix1 of T1. Ix of T1 is minus 0.5. So this is Ix1 of T1 plus Ix2 of T1. So Ix1 is contributed by the 25 volt source and Ix2 is contributed by 2 ampere source. What current flows here because of 25 volt source is Ix1 and what current flows here because of 2 ampere current source is Ix2. Both are considered at the interval T1 or at the time of minus 0.5 seconds. Okay, so at minus 0.5 seconds, this is the circuit configuration that we will be getting. So let us first find Ix1. Ix1 will be, we need to short these two paths. So you will be getting 25 in series with this resistor and then in parallel with it you will have a resistor. So since I am considering only this, I am going to open circuit these 2 ampere current source. Then we have a 50 ohm resistor here. So this is the configuration that we have now. Oh, okay. So this is the value of Ix1 of T1. Okay. So to find out, you can do by two methods. Either you can find the effective resistance and find the total current, or you can apply Kirchhoff's laws. Either way, the answer is going to be the same. The effective resistance of this will be 50 plus 25 parallel with 50, which is 25 into 50 divided by 25 plus 50, 75. The effective resistance is 50 plus 4 into 50, 200 divided by 3 ohm. So what is Ix1 of T? This will be 25 volt divided by the resistance, which is 25 volt divided by 200 by 3. Okay. So what is Ix2 of T? Ix2 of T is the current that is following into this path due to the 2 ampere current source. I write it in another pen so that it is not confusing for you. This is case 1 due to 25 volt. Now we are considering 2 ampere source only. And then we are finding Ix2 of T1. Okay. So the circuit will become, we are going to short circuit these and then have only 2 ampere source. Then find out the effect of this source over this current. Okay, now we have only a 2 ampere source, we have short circuited the 25 volt source. So this current will be, by intuitively we can solve this. We have only one pair of nodes and we have 3 resistors connected in parallel. Okay, so the effective resistance will be the parallel combination of all these 3 resistors, right? So 50 parallel with 50 will be 25. 25 parallel with 25 is connected to a 2 ampere. Its 2 ampere will be shared equally by these 2 resistors because they are in parallel and their magnitudes are same. So 50 parallel to 50 is 25 and 25 parallel with 25, you will be having 1 ampere flowing into each of these resistors. So in the parallel combination of these two, 1 ampere will be flowing. So which means 0.5 ampere will flow through each one of it. So Ix2 will be minus 0.5. Here you can solve it like this by using these tricks, or you can do the mainstream method. I will do the detailed explanation for you now. The total resistance will be 50 parallel with 50 parallel with 25. Alright, 50 parallel with 50 is 25. 25 parallel with 25 is 12.5. 25 parallel with 25. So this 12.5 ohm is receiving 2 ampere, and this 2 ampere is shared by these two resistors because they are connected in parallel. So each one of them receives half of this current. So each 25 ohm resistor will receive 1 ampere of current. So that 1 ampere is in one path, another ampere is, I'll draw it. You have a 25 ohm and then you have another 25 ohm. To this, you have a 2 ampere source connected. Alright, so since these are equal, the 2 ampere splits into 1 ampere each. That is what I was saying. Okay, so this current is 1 ampere, this is 1 ampere. This 25 consists of a breakup of two resistors, which is 50 ohm and 50 ohm. So to each of these, half of this will be flowing, which is 0.5 here, 0.5 ampere here, and then you have 1 ampere here. So that 0.5 plus 0.5 plus 1 makes up to 2 according to KCL, right? So Ix2 will be minus 0.5 ampere. Okay, got it? We have found the value of Ix when the time t1 is minus 0.5 seconds. It is Ix1 plus Ix2. What is Ix1? Ix1 is 0.375 plus what is Ix2? Ix2 is minus 0.5. This is the value of the current Ix of T1. Okay. So at T1, what is the value of Ix1? Ix1 is minus 0.125 ampere. Okay. So similarly, for the time T2 of plus 0.5, we will find out the voltage levels at each different points, and then what is the status of the switch also we will find. Then we will draw an equivalent circuit at time t equal to 0.5 and then solve it. Now what we will do? We will draw the voltage levels at the time t2 of 0.5 second. So this switch status also we don't know. This status also we don't know. At t equal to plus 0.5 second, what will happen to this 25 volt source? At plus 0.5 second also this is supplying 25 volt. And what about this? When this is plus 0.5, this is supplying 0 ampere. Because only for time t less than 0, this gives a very steady output. After time t equal to 0, this has no output, or this current is not working, or this current supplies 0 ampere. Either way you can say. So let us consider this to be a open circuit now. Because when a current source doesn't supply a current, it means that this is as good as a open circuit. Okay, so at t equal to plus 0.5, you still don't get any output here. Only at time t equal to 1 second, you have 100 volt coming from this. Okay, so this is still a short circuit because this is a voltage source. A voltage source supplying 0 volt means there is no potential between these two ends. So whatever is the current that is coming here is the current that is coming here is the current that is coming here. So there is no potential difference. Had there been a potential difference, these currents would not be same. Okay, so this is replaced as a short circuit voltage source, and this is replaced as an open circuit current source because it supplies 0 ampere. So at time t equal to 0.5 seconds, this switch is also in open condition. This switch is closed only at time t equal to 2 seconds, or only at the second, or only for t4 and t5. You can see the effects of closing of this switch. Okay. So this is how the circuit looks like when time equal to plus 0.5 seconds. This is T2. Okay. So for this, what is the value of Ix? We need to find. We have only one source here. It's making our job easier because we don't have to apply superposition theorem. If we have two sources active at a given time, we need to apply superposition theorem to find out the contribution of each one of its source. If you want to have a better idea about superposition theorem, click this link where I have explained this theorem in a very detailed manner. Okay, so let's get back to this circuit. So now we have a 50 ohm resistor, and then we have 25 and another 50 ohm in parallel to this. I'll redraw the circuit for your understanding. 25 volt sources here, then you have 50 ohm in series, then you have 25 in parallel. Alright, this is an open circuit, so we'll forget that. This is also an open circuit, so we have a 50 ohm between this end and this end. So I hope this is a child's play for you guys now. Ix at time t2 will be the total voltage supplied, which is 25 volt, divided by the effective resistance. Ix at time t2 will be 25 divided by effective resistance is 50 plus 25 parallel with 50. Okay, we'll just park it here. We will find out the value of 25 parallel with 50 and then add it to 50. 50 divided by 25 plus 50, 75. This is 16.667. So the effective resistance will be 50 plus 16.667, which will be 66.67 ohm. So I am going to directly substitute in the place of this. Okay. 0.375 ampere. So at time t2 equal to plus 0.5, a current of 0.375 will be flowing here. So this current is 0.375 ampere. Now let us consider the effect of this circuit at T3 of plus 1.5. The reason we are solving this problem at different time intervals is to understand the switching effects. You don't have any transient element here. This is basically an easy circuit. If you know at what time, what will be the response of the power source. What will the power source do? Whether the power source will be supplying power or is it not supplying voltage? Say for example, this we had a voltage source here. So since it is not supplying voltage at time t equal to plus 0.5 seconds, we are considering 0 volt. 0 volt means short circuit. Okay. So if this is a current source and if it is not being useful to a circuit, we will be replacing it open circuits. These basic concepts, once you know, you can solve this problem just like a child's play. So now we will do for the other condition of plus 1.5. At time t equal to plus 1.5, what will happen? At plus 1.5, this will be useful and then this will not be useful. This will be useful. Useful means it gives some power, it gives some voltage or it gives some current in case of current source. So that is the meaning of that being useful. So at time t equal to 1.5 seconds, what will happen to this? This at 1.5 will be supplying 25 volt. So this part we are not changing. I am just replacing this. This is T3, which is 1.5 seconds. Okay, at 1.5 seconds this will be supplying 25 volt, and at 1.5 this is still a open circuit, and at time 1.5 the switch is still open circuit. Only at time t equal to 2 seconds this will be converted to a short circuit. Okay, so at time t equal to 1.5, you will have 100 volts between these two ends. So this is not a short circuit now, this is a 100 volts. Okay, so the topology of the circuit is now changed. You have two circuits, you have two voltage sources now. You have to find out this current. Let's use KCL now to find out this. Okay, so by KCL we can find out the current that is entering each one of the nodes and the current that is leaving each one of the nodes. You can also use superposition theorem like we did for the previous case, like we did for this case. You can also apply superposition theorem, but now just to have a mixture of concepts in this problem, I am going to solve this by KCL. I'll first redraw the circuit for your ease, because we have so many open circuits, so many short circuits. Okay, so we have a 25 volt in series with 50 ohm. I am marking this as Ix of 3. I'm marking this as Ix of time T3. Okay, so let us not complicate this. For now I can say this is equal to I3. Okay, so just for our ease I am telling this is I3, because every time I find it kind of lazy to put Ix or bracket T3. I may sometimes mistake it at Ix3 of T or Ix of T3, or this is seeming confusing to me. So I am just going to replace this as I3, simple terms. Okay, so at I3 it means that the current that is flowing into this circuit at the time T3 of 1.5 seconds. Okay, so this current will be, let us mark this as Vx for REs. Okay, so this is an incoming current, and this is also an incoming current from 100 volt. This is an outgoing current. So by KCL we can say 25 minus Vx divided by 50 plus 100 minus Vx divided by 50 is equal to this current. What is this current? Vx divided by 25. If we solve, we will be getting 25 plus 100 is 125 minus 2 Vx is equal to Vx by 25. I am just cancelling these terms here, and then I am cross multiplying the denominator. So I will get 125 minus 2 Vx is equal to plus 2 Vx. So what is the value of Vx? 125 divided by 4 is the value of Vx. So Vx is now we have found out the value of Vx. So let's find out the current I3, or the current that is flowing into this branch between 25 volt and Vx. You'll find I3. I3 will be 25 volt minus Vx, which is minus 31.25, divided by 50. So what's the value of Ix3? It is minus . So I hope you have a very better idea of this problem, and it is so easy for you to solve these both conditions. At time t4 there is only one change, because this switch is going to be in off position after time t equal to 2 seconds. So for these two time intervals, this will be considered as short circuit, meaning that nothing is going to flow through the 50 ohm and the current will straight away go to the short circuit back to this 100 volt. Okay, so let's redraw the circuit. For T4 is equal to plus 2.5 seconds. What will be the value of this? At time t equal to 2.5, this will be about 25 volt output, and then the 2 ampere current source will still not respond, because only for time t less than 0 you will get a current out of it. So after t greater than 0 at time t4 equal to 2.5 seconds, this current source will still be a open circuit. Okay, so there is no change in this. This switch is now shorted. So quickly look at the question and hope you can relate the question now. At time t equal to 0, you can understand that this switch will be in closed position. At time t equal to plus 2.5, this will be supplying 100 volt. So this will still be active connected in this circuit. Okay, so for this you will understand now that the current is flowing from 25 volt back to this node. You have two resistors here. Since this is open circuited and this one is short circuited, the current will now flow from here to here, and then it will split into this path where it will jump to this short circuit back to the 100 volt and then it will circulate back here. Okay, so nothing is going to flow between the ends of 50 ohm resistor. It is as good as throwing away this resistor from this circuit. Okay, so let's figure out the circuit now. So we need to find this current Ix at time t4. Like I said, I will call this as short as I4. Okay, so just to avoid too many variables into one single current. Okay, so this current is now I4. What is I4? I4 is flowing through 50 ohm resistor. Okay, between these two ends we have three branches. One is 25 volt plus 50 ohm, then the 25 ohm resistor, then we have a 100 volt voltage source connected directly across these two nodes. So the voltage across this is 100 volt. What is the current through it? 100 divided by 25, 4 ampere. 4 ampere is flowing here, right? So what is this current? This current is the sum of the current flowing into the 50 ohm and the current that is flowing into this. Okay, so let me say it is coming here. So adding both these, you will get 4 ampere. Let us apply Kirchhoff's voltage law into this loop. So by KVL, we can say that 25 minus I4 into 50 minus 4 into 25 equals 0. So this implies this is 25 minus 100 minus 75 equals 0. So it implies I4 is minus 75 by 50, which is minus 3 by 2 minus 1.5 ampere. So at this case, when time is plus 1.5 seconds, you will have different levels of voltages and currents flowing into this circuit. Therefore, the value of I4 changes to minus 1.5 ampere. Okay, so last question, it's super easy. It's just like this problem, but at time t equal to 3.5, what will happen to 25 volt? The 25 volt will get tired because till t equal to 3 seconds, it was still acting. It was acting at time t less than 0, at greater than 0, till time t equal to 3 seconds. So at time 3.5 seconds, this goes to 0. This is now a short circuit. Right? At T5. Okay? At T5, this will also not act. So this is still a open circuit at time T5. And then what happens to this? This will still be a short circuit because after time t equal to 2 seconds, you are just closing this switch. Okay? What about this? At 3.5, this will be active and awake. Okay? So this is the only power source for now at time t equal to 3.5 seconds. So what is the value of Ix? Ix will be 50 parallel with 25 parallel with this. Okay, this 50 is also not there. So you have a 50 parallel with 25 connected in parallel to 100 volt. What is I5? I5 will be minus of 100 divided by 50, which is minus 0.5. I'm going to explain this in detail. I'll replace the circuit, I'll redraw the circuit like just like I did in the previous cases, and then I'll find I5. Okay. Circuits like this, sometimes it will be very overwhelming. You might think that it's so complicated, you have to redraw the circuit each and every time. But once you get the concepts right, once you have practiced so many problems by yourself, the moment you look at the circuit and I say, okay, at T5, what's the answer? Just by looking at the configuration, you will be able to find out the value of the current. That level of practice is actually needed for competitive exams. And if you are trying to understand the subject in depth, you need to solve more problems instead of reading more theory questions. Because only when you do problems, you will challenge yourself at different conditions. What if this is given, what if this is asked, what if it is put into this condition, what if the circuit is in this time, what if the circuit is in this time, what is this switch is closed, what about if the switch is not closed. You will have so many options to think about. Once your brain is busy with so many things, it will learn and you will have a very strong base of the concept. Coming back to the earth, okay, we are just going to solve this problem again. Ix of T5 will be the voltage across the ends divided by the resistance. Since this terminal is positive and the current direction is considered from bottom to top, this is in negative. Okay, so Ix of T5 will be minus of 100 volt divided by 50. Yeah. So this is minus 0.5 ampere. This is a very basic concept problem. It doesn't even involve any transients actually, but you need to understand these switching cases. Once you understand these cases, you will be able to solve the problems in transient analysis very easily. I am sure in the exams that you are going to write, you won't be getting problems like this. You will be getting problems which has an inductor or a capacitor. But this is actually a pretty simple problem, but the switch is disguised in the form of unit step functions. Okay, so now you would have had a better idea of this case. So in the next video, we'll start with a new topic of RC Transients. Thanks for watching. Let me know your thoughts in the comment section. Subscribe to my channel for more updates. Thank you.